Welcome to Risk Revolution, a podcast series that examines all aspects of risk management in the life sciences industry. We'll talk to industry experts on best practices for identifying risk, assessing risk, measuring solutions, implementing solutions, and monitoring results. Here are your hosts, Nuala Callan, Valerie Mulholland, and Laurie Richter.
Hey, welcome back to Risk Revolution, our monthly series seeking to advance the maturity of risk management practices across the life science sector. And as usual, we'll cover topics that challenge professionals within the biopharmaceutical and medtech industries. And as always, we aim to shake up the paradigm to revolutionize the way in which we perceive and proactively manage risk. So listen, Val, we're back in the studio today after our field trip last month from our live episode at the Q1 Scientific Stability Conference. What fun we had out and about, gadding.
Absolutely, but we're back at base this month, thankfully. But another exciting episode because everybody, everywhere, all at once is talking about this month's topic. So it's time for us to dive in to this Risk Revolution episode. And we have Laurie back with us. What's the hot topic for discussion today, Laurie, and the learned guest you brought to tell us all about it?
Yes, absolutely. And I do want to just preface, I'm sorry that I missed joining you. I'm sure it was a lot of great fun and I would have loved to have been there. So I'm glad to be back with you this week or this month. So today we're going to discuss artificial intelligence. As you said, everything that everyone's been talking about and what can it do for pharma. So my guest is going to be Mike Salem. Mike is an expert in AI with over 15 years of experience, but Mike's had a really varied career, which I found to be very interesting. He has a background in mathematics and computer science. He's worked in several industries, including defense, education, finance, and also in pharma, obviously. The design of this podcast is to take us from the basics. So we'll start from an introductory sort of level of definitions and terms, and then we'll move through how we can leverage AI in our QRM programs, given that we're Risk Revolution. We'll talk a little bit broadly about pharma, but we'll zero in on the quality risk management components. And we're going to talk about this all in the context of keeping humans in the loop.
Well, that's fantastic, Laurie. By the way, where did you meet Mike and how on earth did you convince him to share his insights on AI with us? How did you strong arm him into visiting with us?
Yeah, actually, it's funny, during the podcast, we talked about how we met, and I couldn't even remember the name of the conference that he had to remind me, but it was PDA week. It was just earlier this year. I felt like I've known him a lot longer than that. He reminded me we hadn't known each other that long, but it was in Palm Springs earlier in the springtime in March. And we were actually speaking at a track on one of the days at the conference. I was looped in as a quality risk management topic in with the AI group. So there was a couple of folks that were speaking AI, and I think I was sort of sandwiched in there. It was really great to listen to him. I felt like he had a way of explaining it that made sense to a lot of people. A lot of people asked him questions at the end. There was a lot of Q&A for him. And so I found him to be very engaging. I ran into him again many months later at a California event that was just for the PDA West Coast chapter. And I said, hey, we should do a podcast episode together. So that's how that played out. He didn't have to be hugely strong-armed. I think he really enjoyed talking about the topic.
Brilliant. So let's get a listen to your discussion. That'll be great.
Yeah, Mike and I go way back. We met actually at the PDA annual week in was that in where was that?
It was in Palm Springs.
Palm Springs, yeah.
Yeah.
I don't even remember where I was. In Palm Springs, and we spoke together at a conference. It was great. So Mike is an expert in artificial intelligence, and that's what we'll be talking about today. But we're going to start off with the basics. So Mike, let's start out simple. When we say artificial intelligence or AI, what does that actually mean in practical terms for people who might be new and don't have really a tech background?
Yeah, so this is a great question, Laurie, and thanks again for having me here. Really appreciate being here, being able to talk with you about this. And when you say we go way back, let's just let people know. Way back means about 6 months. Okay,
right,
so
earlier this year.
It's old hat by this point, For,
right.
For
I get attached really easily, Mike.
Yeah. But before we get started, Laurie, I just want to mention that, the views and the ideas and concepts that we're discussing here are solely my own and don't reflect any companies that I've worked for, past or present.
Absolutely.
So when we talk about artificial intelligence is really kind of this intersection between what I consider basically math and computer science, right? So it's all about getting a computer to behave in a way that a human would work. Okay, so that was the original concept of what artificial intelligence was really about. When you go back into like the 1940s, I believe, with like Alan Turing, and you start looking at World War II and the Enigma machines, the whole concept here was to have machines do work that humans normally would have to do and behave kind of like humans. So making decisions, being able to reason, being able to perceive objects or understand sounds. So that's really the kind of general framework for what artificial intelligence was and is. As you move through history and as you move forward into this kind of paradigm that we've entered, it's went from being a lot more algorithmic, a lot more traditional mathematics, things like probability and statistics, to being kind of expanded upon, because now we have the ability to kind of not only take the math that we have, but couple that with the computers, right? So we have the ability to do the computational power, whereas before things would be purely theoretical. So we would be able to say, well, in theory, if we had, 7 million examples of this, then we could mine that information to do something. Well, fast forward till today, we actually do have those 7 million examples, right? So it's really being able to kind of combine together the ability to take some of that math, apply it with the computer, and then get a practical insight into whatever kind of process or thing that you're looking to do. So whether that be analyzing a picture, whether that would be generating some sort of text or generating some sort of audio, or making some sort of decision or prediction based on some past or recent events.
It's crazy the way you describe that. I love it because it's really interesting to think about where we are today and where we had to start, the foundation we had to lay to get and the sort of iterations we had to make to get to where we are today. I always find that kind of fascinating. I wonder sometimes if those people back in that time realized what it would look like today, if they sort of had that vision, or how far off we are from what they thought it would be, or if it's far surpassed what they ever thought it would be. I always find that part kind of interesting too. I wonder what they would
It's
say.
so I think this is one of the most exciting things in kind of being around today and being able to see this is we've seen a lot of that progression. We've seen the progression from these machines. We've seen the progression of the internet, and we've seen the speeds that have come with that, the computational power that's come with that. We're seeing the distributed and high performance computing kind of explode, right?
Yep.
We're getting the ability to kind of see where this is going, and it's accelerating faster and faster, right? So if you look
Yeah.
at Moore's law was all about the idea that the number of transistors on a chip will double, or they'll move exponentially, right, with each
Yeah.
iteration. We're now moving into that point where we're starting to see artificial intelligence kind of accelerating at these kinds of rates too, which is really kind of mind-boggling,
Yeah.
considering really the speed and the type of problems that we're trying to tackle.
Yeah, it's really amazing. Really fascinating time. So there's a lot of buzzwords, and I loved what you even just described with the history. So let's move into kind of some of the terminology so that people can
Okay.
wrap their minds around that. We're hearing things like bots, generative AI, predictive AI, machine learning, and you used possibly some of those things even in your description. Maybe you didn't, but can you break down the different types of AI? And how they're maybe applied in pharma today. Where are you seeing possibly some of these things, or even potentials for some of these things?
Yeah, so let me give you just kind of a general overview, I think, of AI, because when we say AI is really an umbrella term for a
Mm-hmm.
lot of different components, right? Like I said, AI is really the ability for a computer to behave or do tasks that a human would do. Okay. Now, when we go back historically and we look at that, a lot of the algorithms that were deployed started out with more deterministic style approaches. So what I mean by that is things like operations research, where you would do things like linear programming, where you would say, basically, given this region, find the optimal, or you do these kind of tree-based approaches where you do branching and you're basically saying, if I move in this direction, if then, right? So
Sure.
those kinds of concepts. So that's kind of the original starting point for a lot of the artificial intelligence, okay? Now, once you kind of peel back that layer and you go into the next layer that we really kind of typically consider is what we consider machine learning. So machine learning is the idea and the ability basically to take data, right, and use it so that the machine can learn from that data. Okay, so what we do is you give the machine, a bunch of information, and then within that, there's a couple of different subsets field essentially. Okay, so one is called supervised learning. So supervised learning basically means I give the machine a bunch of data, and then I tell the machine what the answer is based on that information that I'm giving. Right. So what we do is we call that information. Each one of those items or records would be considered an instance. Each one of the columns or inside of there, whatever kind of data that you're looking at, we call a feature. And then we basically say we have these instances and these features, and then we have some sort of output. Okay, so we give the machine a bunch of those, and we say, hey, this is what the answer should be. And then what you typically do is you test the machine, right? And you say, okay, great. Now that you've learned off of that information, here's some new information, and how would you do? And typically, even for that information, you know the output. So that's why we consider testing it. And then you look at it and you basically say yes or no, yes or no. And then you can go back into this loop and kind of iterate and kind of redefine the machine and retweak it a bit. So that's what we consider supervised machine learning. Then the other concept here is what's considered unsupervised machine learning. So unsupervised machine learning basically means you give the machine a bunch of information, and then you say, I don't know what I really want to do with this, let's say. How could you help me kind of organize or structure this a bit better? Okay, so the way I like to explain this to people is, imagine you have a bunch of Lego in a box, right? And you take a bunch of Lego and you dump them on the ground. What would you do to kind of organize that? Well, you might organize them by shape. You might organize them by color. You might organize them by set. But really what you're doing is you're grouping them together based on some sort of common theme or common structure, right? So oftentimes when they do this with unsupervised machine learning, the way that they're grouping them is basically based on those features, right? So it could be the color, it could be the numbers, whatever the case may be, and you're kind of building out these different types of groups, okay? So then the last version of machine learning here that we typically talk about, which gets neglected a lot, unfortunately, is what's called reinforcement learning. So the idea of reinforcement learning is that the machine is learning what the rules are kind of as it's behaving, right? As it's exploring. So imagine you're playing a game like tic-tac-toe. You've never played tic-tac-toe before. I don't tell you the rules. I give you some very basic information. You're X, I'm O. You make a move, and then eventually I win, and I say I win. And you look at it and you go, I don't understand why you win. And you go, oh, it's because I got 3 in a row. And then it starts to understand after a while, oh, 3 in a row is what I'm looking for, right? So instead of randomly moving, I need to start trying to strategically align how I can get to 3 in a row, right? So it's the idea of this basically reward penalty-based system that allows for the machine to kind of start to understand, this is a good move, this is a bad move, okay? And reinforcement learning is really starting, I think we're seeing a lot of good applications of this in robotics. This is really starting to become more of a forefront because now we're looking to kind of tune these models, whereas before with like supervised machine learning, you basically said, here's the answers, and then here's some test set, and then we kind of go. Now we're kind of saying, here's some answers, here's the test set. You've learned, you've done well, but now let's continue to kind of iterate and train on this as we kind of go too. So new rules, new paradigms, new shifts kind of allow for some of that information. Now, once we go under the machine learning umbrella and we move in deeper, then we get into deep learning. So deep learning is really the concept of looking at things more like neural networks. So when you start hearing a lot about the AI that we discussed today, it's really around these idea of neural networks. And what the idea here is that you were trying to mimic what happens with the brain, right? So the way that humans think is the goal has been to utilize the way that humans think and use that as a framework to kind of help push for what needs to be done from a machine perspective, okay? Not exactly, but more or less for all intents and purposes for a layman. The idea here then is we take these neural networks and we make these really long, deep, complicated versions of them, right? So in a way of, so this is where it differs from classical machine learning, where in classical machine learning, they would do these neural networks, but they would do shallow, maybe 1 or 2 layers. Now we're doing these really deep layers with a lot of different computation as they go through. And where these start to really shine is they really start to shine in doing image analysis. So to do things like identifying cancer tumors or looking for segmentation of different objects, right? So if you're looking at self-driving cars and you're looking at, a scene, right? You can say, hey, that's a pedestrian and that's a street light. And this is the road that I'm supposed to stay on. And those are buildings. So I don't want to run into those, right? So that's kind of one of the biggest areas that we've seen from deep learning. And then the other category for that has been for text and speech generation, primarily more on the text-based. And that text-based is basically the idea that as you're predicting, you're only predicting just slightly ahead of where you are, okay? So that is really kind of the basis and the foundation for where generative AI comes from, right? So it's a slightly different architecture than some of these previous architectures, which were reoccurring neural nets to do that kind of a work. And now we're getting into the point where we're doing that for more text generation, looking at historical examples and things like that. And that's where generative AI starts to come in. And then the other aspect of generative AI is doing image generation. So the way that that works is basically you give a machine a bunch of images, and then you say, I want you to kind of create new images based on those images. And then you basically have a critic look at those and say, well, that's right, but not right. Here's what's wrong, and here's what needs to be done. So the machine's goal is really to kind of get to the point where it learns how to fool the person who's judging it. And the person who's judging its goal is always to try to detect the fraud. So once they get back and forth, it's kind of a cat and mouse game. And once the machine gets good enough, that's how we start to see images that we're seeing today, right? So that's basically the gist of those. Now, when we talk about bots, bots have different frameworks, different meanings for different periods of time. So a bot historically was always around this idea that it would do something in a machine, right? Like in an automated way. That could be deterministic. So we used to be able to say, oh, we have a bot. A bot was basically like, hey, it went to the website, it scraped this information, and it put it in a database. That was considered a bot. Over time, terminology kind of changes, or buzzwords kind of change. So bot now has always been kind of that kind of dumb idea, right? If you look now, we're starting to move into this concept of what we call an agent, okay?
Yes,
so an agent now is really more of something similar to a bot, but it's really using more AI. So this has the ability to have a lot more complex reasoning kind of built into it and a less explicit programming. And with that, we use that information to kind of say, okay, you as an agent, go and do this thing, and you kind of can figure out based on the tool set that you have, and then you go interact with this item, and that's what makes an agent, right? And then it says, okay, based on being able to extract or grab that information, now we have that, and then we can do X, Y, and Z with it. So agents are kind of a more complicated and loose framework of a bot.
Okay. That helps tremendously because I think I was using those kind of interchangeably when it sounds like agent was kind of a spin-off of bot, but with a more complicated, complex sort of series of things it can do, I guess, and the interaction
Yeah,
between
and there's been difference in terminology as we've gone. We've went from bots to robotic process automation, which was another component, right? Where there's a little bit of fuzzy logic that wasn't involved, but it was basically deterministic. Now we're going into agents, which are basically like, hey, there's this large language model, which is this generative AI kind of component, and it has the ability to interface and interact with these different tools, right? And then when you take a large language model and you couple it with some sort of a tool, whether it be a database, an internet search, whatever, then it becomes an agent. Okay. So a little bit of it is branding too, which is okay, right? I think that's good because you're trying to distinguish different versions of technology. But if you've been following the field long enough, you're starting to see, I think, from my opinion at least, maybe others in the field will disagree, and that's okay. I think you're starting to see it's a lot more nuanced, but it's not really that different than where we were before, right? We have some new names for some different things. Some of these ideas are kind of re-emerging because the technology just wasn't fleshed out at the time. They're coming back now, and the ability, based on previous, success criteria, if it didn't happen, right, you don't want to call it the same thing because people are going to say, we tried that, it didn't work.
Right. We've done
now
this
we give it a little bit of a new name, and then we can try it again. And now we can showcase that does work because we're trying to distinguish that it's a progression. So I don't think it's necessarily a bad thing. I think it's a good thing. I just think that that's the way it's going to work probably from now and forever. So as long as you understand your history, you're going to kind of be able to move and adjust with it pretty quickly. If you've never heard any of these words before and it's all new buzzwords to you and you have no background in the area, it becomes daunting because you're saying, oh, I have to learn all of this stuff. And then in 3 months, all the words have changed again. So you're always playing this game. So really what helps is to understand the history. And if you understand the history, then you can say, oh, wait, that sounds just kind of like this. Oh, but you did this to it. Okay, fine. I know what's going on.
Right. And I think conceptually being able to understand what's going on there. I think the way you described the learning I found very fascinating because it was so human in terms of like the reinforcement learning. It's really funny to watch people, a line of people, and the first person has to do the activity, whatever that thing is, and they sort of fumble through it. And everybody else behind them is watching this and they're learning already from this observation and they're adjusting their strategy. The second person does something, typically does it better, right? Because they've already watched one person do it, but they're still stumbling. Meanwhile, third and fourth person are learning. So hearing you describe that, I was like, God, that is just so how humans learn, right? And watching them learn. So now realizing that kind of fitting that into this AI platform sort of is helping me make sense of everything too. It's
Yeah, and
scary.
that's always, I think, been the intent here. The intent here is really to look at what do humans do, because humans are fairly efficient, believe it or not. And we're pretty
Yeah.
energy efficient as well. So this has always been, I think, an inspiration for a lot of folks in the field and a lot of researchers, because really what we're trying to do is we're trying to say, okay, if a human can do it this way, can we get a machine to do something similar, right? We
Yeah.
all, well, I shouldn't say we all, but I think most of us would probably agree that it's not going to be identical, right?
Right.
But there is going to be the potential to say there's a lot of good things that humans do. Is there a way to kind of replicate that through some of the software and some of this hardware? And I think that's where we're going. And now we're starting to see the evolution of these new chips that are also meant to kind of mimic those pathways a little bit more and do things a little bit
Yeah.
more efficiently, as opposed to the kind of these general chips that we had before, which is really,
Yeah.
really interesting.
We'll have you come back for the tiny brain discussion that I definitely want to have that we're starting to mimic. I have so many questions. So, but let's move on to quality risk management because that's what Risk Revolution's all about, or at least risk in general. Let's shift into some specifics here. How do you see AI boosting a company's QRM program? What do you see are some aspects there that could help?
Yeah, this is a really good question, Lori. I think when we start talking about quality risk management, quality risk is really all about trying to be proactive, right? And it's all about looking at prevention and being preventative. And when you start looking at that, I think the best opportunities in the quality management space, right, within pharma or biotech, really kind of come from looking external. So there's a lot of other areas where there's a lot of risk. And I think one of the areas that has the most risk actually is finance. And I think finance does a beautiful job of modeling risk and understanding risk, right? So I think what you're trying to do is you're trying to look to see what are our algorithms or what are components that actually work well for doing predictive control, right? Doing predictive modeling. How well are we at forecasting? Which algorithms typically work well for what signals? And then can those algorithms be applied in a different realm? And if they can, great, right? So I
Yeah.
think the biggest challenge that we have a lot of times is that people don't talk across industries. Now, I've worked across multiple industries, so I've seen problems where I've been like, hey, this problem that shows up in robotics is the same problem that showed up in finance. It's the same problem that showed up in healthcare. It's the same problem that showed up when dealing with people in social dynamics. So if that's the case, it's a common theme. And so I think most problems are solved problems, is really what I think it is. I think it's a matter of where are you going to look for those problems. And I think in the quality risk management space, I think for some folks, it's still a relatively new area. And when we move away from the classic analytics of looking historically and saying, okay, we're going to use what's here in the past and analyze it, the problem is that becomes a lagging indicator. So whatever happened, by the time I analyze whatever happened, it's already done. The risk has already been presented.
Yeah.
Now, if I'm looking at that information and I'm saying, well, where is this information going to go? Like maybe I'm starting to see something trend up. Maybe I'm starting to see a new area emerge that we haven't seen before. Then that becomes a different way of looking at things. It becomes a different paradigm. And now you're starting to use your data in a different way. So I'll give another great example, kind of going back to the financial realm, is fraud detection. Fraud detection is a really big thing. If you start looking at these rings of people moving money around or moving products around, there's a lot of challenge with that because all of a sudden you have these really vast, complex networks, whether it be supply chains, whether it be, routing numbers, whatever the case may be. And then all of a sudden you see these blips that just pop up once or twice, right? And then they go away. Well, are those fraud? Right? Are those real actors? How do you detect those within the network? Right? So I think some of these concepts and some of these things are going to emerge over time. And it's going to be really an exciting field to kind of be a part of as we're starting to look more at how do we bring AI into this realm within this industry, right? To see how can we leverage that. And I think the first way that we should do that is look outside of our industry and say, hey, what's going on out here? How well does this work? And if this works well out there, can you show me what you think we should do, right? So I think cross collaboration is going to be really important for that.
Oh, I think 100%. And I think something you said too, and I've been thinking about is, again, I go back to AI is really a tool. And I think if we don't have the right mindset, this tool is still not going to help us. And so back to your think, we have to be thinking, do we really want to be predictive? Are we really trying to think ahead? Because a lot of times I feel like we're still stuck in that firefighting mode in the industry and we're comfortable there for some reason. And it's hard to break out of that. I know when you look at areas like finance, um, even areas of the business strategy, I'm sure they are very forward thinking, but in a lot of ways in pharma, we really get stuck kind of in a place of, oh, this thing happened, we got to deal with it, versus where do we want to be in 5 years? Where do we want to be in 10 years? I mean, I just bought the iPhone 17. I'm sure back at iPhone whatever 4, they already knew what they were going to do for 17 because that's how they think, right? They're well in advance so that they can keep sustaining that model, so I keep going back and buying another phone, right? I think that's kind of where we need to start being, but I think we struggle with that a lot of times in our industry. So my thinking is we need to get that mindset before we can even really start using some of these tools, right? Because we're not going to have the right information to even feed the tool if we're not already thinking that way, I guess.
Yeah, I agree with you, Lori. I think the mindset is critical. Okay. And I think the idea and the ability to kind of say, historically, we've done it this way, it feels familiar to people, right? And
Yes.
when it feels familiar, it feels like, hey, I know I'm going to get the job done. If you're
Yes.
giving me something new, I don't necessarily know if I'm going to get the job done, right?
Yeah.
So I think what it really is there needs to be an established relationship between the tools and the user to ensure confidence and instill confidence.
Yeah.
And the more
Yeah.
confidence that we can create with the end user, the more adoption that you'll be able to drive.
Yeah.
Okay.
I agree.
So when the other thing I think people need to really kind of consider is a lot of times, in the tech field, working in software and working in some of these areas throughout my career, uh, there's not really as much forward thinking and forward planning as you would expect, right? So, to your point of like, oh, the iPhone 4, they already knew what they wanted to do with the 17. Chances are they probably had no idea. Okay. And the reason I say that is a lot of times the tech moves so quickly that whatever the plan was at 4, by the time they hit 17 was drastic. Okay.
True, true. Good
And,
point.
and and the reason is tech cycles are incredibly fast. All right. So historically, companies, in pharma and things like that, you have your 5-year plans, your 10-year plans. Some places probably even have 20-year plans for all I know. Okay.
Yeah.
In tech, anything past 3 years, we start to laugh a little bit, right? Because the reality is we're like, who knows? Because 2 years ago, we were using this technology, and now this technology came in and it's significantly faster. Okay. So I'll give you an example. Back in like 2012, 2014, Hadoop was kind of really the big thing. It was this framework that was built by Google. Everybody was going crazy about it because it was allowing everybody to bring all this massive information together and, compile it across all these different machines and do this distributed computing and do what was called a map reduce. So you can aggregate all the information faster. Things that you wouldn't have been able to do on a single computer, you could now do by clustering computers and do it in maybe, 15 minutes, let's say, right? Well, that was massive. That was huge. Well, a couple of years later, Spark came out, which was like, hey, by the way, instead of having to write to disk every single time for every single computation, we're going to do not as much of this as possible in memory and only write to disk when we need to, which was a drastic speed,
Oh,
right?
yeah.
So what happens is all of a sudden you say, hey, we were on this technology, but now this technology emerged. And I think the tech industry is usually pretty good about we have to switch. And the reason we have to switch is because we have to keep up with the costs. We have to keep up with the talent, right? And we have to keep up with the workload that's going to increase, because what happens is you go from saying, well, I can wait 20 minutes to, well, now all of a sudden my competitor is pushing out a product and their product takes 2 minutes instead of my 20 minutes. I need to move to that product now too, because if I don't, no one's going to use my product anymore.
That's right.
And I think there's a lot of failure or like, decision paralysis that kind of comes about because you're saying, at what point do I get going? And the reality is in tech, we're so used to it that it's like, hey, I'm building this starting today. And then 3 weeks from now, all of a sudden some new technology comes out and we're like, hey, that's better than what I'm doing. I'm going to switch over and see if that works. And if I can use that, leverage that going forward, I will. Now, there's always cutoffs and there's always stable points that have to happen. So it's not all the time everything is constantly being broken and redone, but usually it's every couple of years or so. You say, okay, for a couple of years, we'll use this, but then we're going to transition in the background to something else.
Yeah. All right. So you broke my whole conspiracy theory that they've been leading me along to continue to upgrade my phone, but knew it probably 10 years ago then. So,
Yeah,
so
I
they
don't know if
changed,
that's
they
the
changed.
case. If that was the case, then you should I definitely want to go work for one of those companies. And then, maybe I can get in on one of the state or government lottery systems and see if they work the same way, where they know what the Powerball numbers are going to be 10 years from now.
Right. All right. I'll give you that one then. Okay. So let's talk about humans in the loop. That's a lot of conversation in pharma, and I think it brings warm and fuzzy to the quality professional that the human is still in the loop. Can you describe to everybody what that means?
Yeah, human in the loop is actually a beautiful idea, and I think it's going to be critical in not just pharma, but in a lot of different industries. So the idea with human in the loop basically means that you have these AI systems or AI agents or machine learning applications that are actually performing the tasks and doing the analysis and coming to conclusions. Now, instead of the conclusion saying, hey, we're going to do X, go execute it and be done, right? Now we're starting to say, hey, we're going to do X. Hey, person who has 20 years of experience and knows what X should look like, is this right? And if it is, then tell me yes, and then I can kind of go and execute it. Or you can go and execute it, or you can have somebody else go and execute it. So human in the loop is really a safeguard and a safety check to prevent AI systems from just doing everything end to end. And I think in some instances, the AI being able to perform a task end to end is going to be just fine. But I think there's a lot of critical instances where we're still going to want a human in the loop to kind of pass judgment. So again, when we talked about machine learning, we talked about the whole idea of looking at statistical patterns and statistical components. So when you're doing a prediction on those things, it's going to draw upon the previous experience. What if it's something that it's never seen before?
Right.
And it's totally radically different. And if that's the case, it has no prior experience to pull from. And if it doesn't, it's going to predict based on the thing that it was closest related to in the past, which could be entirely incorrect. So
Right.
humans are a little bit better at being able to come up with a creative solution to something that they've never seen before. So that's why I think human in the loop is always going to be a critical component, because when we hit those edge cases, we're definitely going to want somebody to be able to look at that and understand that. And maybe we want teams of people to kind of get together and discuss that before they figure out what's the right path forward.
Yeah. And I love myself. I love when I've had some level of AI interaction where it has done some analysis for me. And I look at that and I go, wow, this is really great. And sometimes it spurs other ideas from me based on what it gave me, right? So I love that human in the loop concept. And let's face it, from a regulatory compliance perspective and from a safety, keep it on the rails perspective, we probably need to have that anyway. You know,
Absolutely. And I think the funny thing here is oftentimes the AI systems actually do better jobs than humans, right?
yeah,
So, I mean, for certain tasks, like I said, when we talked about medical imaging earlier, right? Whatever's in the
yeah,
image, the AI system is going to find that, 100% of the time if it knows what it's looking for, right? It's
that's right.
always going to find the thing that it's trained to look for every single time, where a human has fatigue, right?
Right.
So there's times sometimes where you're looking at it and you're like, oh, I just didn't see it, right? The machine is programmed to be able to do that. That said, there's also times where these machines can just go off the rails for different things, right? If you give them
That's right.
too wide of a space to kind of operate, right, they do a bunch of different things. So one of the examples is I've seen AI agents used for code generation and some of these kinds of components that when left to kind of work on their own, they kind of spiral out of control without a human in the loop. So
Right.
the way I look at some of these newer Gen AI type systems and the way I describe them to other people is treat them like an 8-year-old, right? So if you give an 8-year-old far too many instructions all at once, or you give them a lot of information really fast, they're going to get lost really quickly. So you have to kind of go really small and really, really contained in kind of these tight iterations. And again, that's where the human is in the loop. The human is in the loop that entire way through it. Now, researchers are working on this and actively aware of these kinds of problems, and these systems are getting better at being able to kind of handle that without having that human in the loop as frequently. But I think there's always going to be a scenario where, just from a confidence perspective, humans like to be involved. It gives them a form of reassurance, right?
Yeah.
But
the warm and fuzzy,
even then, in reality, in some cases, the machine will actually already be better than the human at that point. But it's just it's a little bit of, I think humans like to feel like we're in control of situations. So it just gives the human the perception, at least, that they're in control when really they didn't need to be in control. But I think it's a good thing, because like I said, those edge cases, when they do crop up, you definitely are going to want somebody.
That's right. So let's talk about, if I were able to provide some data. I'll just make something up, actually. I have a piece of equipment's manual, user manual, and I just purchased this piece of equipment, and I'm in a manufacturing facility. If I were to give some sort of version of AI this manual and say, here you go, would it be able to generate some kind of risk assessment for me to help maybe with my maintenance program or my calibration or something like that? Because now it's been fed this information. How can we use this to possibly help us start to generate risk assessments?
Yeah, that's a good question and a good use case, Lori. So I think what happens is, the answer is always, and nobody likes this answer, but it's always, it depends. Okay.
Yeah.
And the reason I say it depends is it really depends on what kind of AI you're using, how much information is involved with that AI agent as part of the background, as the training. Different models perform well at different things, right? So in the same way that you can't say, if I'm a baseball player and I can hit 50 home runs, then clearly I should be like one of the best golfers in the world, right? Because the swing is entirely different and the sport is entirely different. So different tools, different techniques, right, for different use cases. So when we start talking about, can we take an AI agent and have it, upload a document and have it do a risk assessment for it? The answer is, it depends. Is that AI agent trained on all of the compliance and regulation that's out there? Is that AI agent have the background and have the necessary information that it's needed, right, to be able to perform those tasks? Because if it doesn't, it's not going to be able to do it. But if it does, you can use that as a starting point. Now, the thing I always would tell people in these scenarios is trust but verify, right? So you might see something that starts to look good, but as you start digging into it, that's where you need to be that subject matter expert. That's where you need to be that human in the loop, is because you might say, well, actually, that's not entirely correct. If a machine says the operating range is between 2,000 and 3,000 RPMs, and now the machine is telling me, for calibration purposes and for optimal performance, you should set it at 45,000 RPMs. I might have a problem, right? That's probably not going to work well in my favor. So a little bit of it, and those are what we call hallucinations, where it kind of says, hey, based on the information that's there, I'm going to give you something that looks like the information that should be there, but I've entirely made this up. And researchers have done a better job of kind of starting to tame these hallucinations. They're trying to work on more factual based approaches in some of these other areas. But the general framework then becomes, really, do you have the right pieces in place? Do you have the right knowledge in place? Do you have the right stakeholders or evaluators in place to understand what's coming out of these agents, right? So there's a lot of pieces that have to line up. And I think some folks might look at these things as more of like a silver bullet of like, I'll just get AI to do it. And I hear that a lot, right? Well, we'll just give it to AI and AI can do it. It's not that simple. If that was that simple, then nobody would be doing anything, because AI would do everything, right? So now we're at this point where it's like, okay, now we're getting to these areas where it's like, hey, we want something specific. And if you want something specific, then you're going to want a team of data scientists, a team of engineers, a team of SMEs, right? And you're going to want them all to work together to start solving those kinds of problems and make sure that the solutions that are coming out are reliable and are sufficient for the needs that you have. So the long-winded answer that I just gave you really boils down to, it depends. It depends on the technology. It depends on the models. It depends on the questions that you're asking, and if everything is well-defined. If it's well-defined, you'll probably have higher level of success than not. However, you could still be unsuccessful in certain instances.
Yeah. And what I'm hearing, though, too, is at the end of the day, it could give you a good start, though. It could give you a framework maybe to get something going, but do not let it go run a supposed risk assessment and let it just go do its thing, but it might be able to provide some good starting material too, or something
Yeah,
like
and from my own personal opinion, I think if you did the full risk assessment and you blindly accepted that risk assessment and brought that into your GMP based system or whatever the case it might be for your processes, I mean, there's a bunch of small problems that lead up to major problems with that, right? One is that, like I
Yeah,
said, this concept of hallucination where it's actually giving something that's outside of the range. Two
right.
now is if you have somebody who's new, who's never looked at that, go and reference that material and has never been trained or is still very new to their job, they're going to have a lot of challenges understanding like why is that being said, because that if that's what's being said and this is how it's performing, then it's within in the system. Three is you don't even know if the risks are accurate,
Yeah,
right? So
yeah,
if no one's looked at it, you don't even know what's really going on. And I think that's why
right.
you always want those humans in the loop. And that's why I think it's critical that we change the mindset. I think when we start talking about a lot of this stuff, the biggest problem I hear is AI is going to take away my job. AI is going to
Yes,
replace me.
yes.
No, AI is a tool just like any other tool. I mean, you have a computer, right? Your computer hasn't replaced you,
Right.
right?
But there was a time we thought that, right?
Right.
We think
So
that about
what
every new
happens is
technology.
things transition and things move forward. Okay.
Yeah,
And one of my favorite examples of this is, do you hunt for your own, meat? Do you eat meat still? If you
right,
do, like, are you going out and cultivating your own cows and chickens and growing
right,
your own crops? No, we go to supermarkets, right?
right.
So certain jobs are going to kind of shrink and certain sectors will grow, right?
Yeah,
So there's always going to be new opportunities. I think the thing is you have to start figuring out now, how do I take my current skill set that I have and what is the future going to look like with that skill set when I combine it with this? And those
yes,
are the things that I think people need to start thinking about. And instead of this kind of doom and gloom that we're being fed in some instances where AI is going to do everything and nobody's going to be able to work, it's like, no, less people are going to do a certain type of job probably because you're going
right,
to be more efficient at being able to do that job, right? That's
right.
the whole concept of machines. You have machines in food processing plants all the time, right? We have
Yeah,
robots that do those things in food processing plants, right? It speeds up that process as opposed to humans having to do.
right.
So the reality then is there's still humans that do work. Well, where does the work come? Well, the work now comes from repairing the machines, from sourcing the machines, from building the machines, from designing the machines. There's different jobs that are being created from another industry kind of shrinking. So it's that whole idea that when one door closes, another door opens, right?
Yes,
So
it's
it's
true.
just kind of trying to stay proactive and trying to understand how do these things impact what you're doing? Why would these things impact what am I doing? And then how do I kind of continue to move with it? And that requires a lot of constant training and constant education, but it requires being flexible too. And I think
Yeah,
this is one of the big things that we said, like you said earlier, right, where we were talking about people like to do what feels familiar. They're good at this and they know it's reliable. Now we're saying, hey, it's okay to experiment and it's okay to try things. And we need to get more familiar and acclimated with the idea that when we try things, they might not work, and that's okay. But at least we've tried it and understood, and we can go back to the thing that we need to if we have to.
yeah. I love your analogy though, because I often use a different one that's very similar though. When people start, sort of bemoaning the future of like a new big technology hurdle that we've achieved, and let's face it, AI is one of those. I always say, "Do you still ride a horse to work? No." Do you tell time by the sun? No. So like there's a lot of things that have progressed in the history of humans, and we just have to shift and pivot and look at the good that those and will there be downsides? Of course there will. There's always downsides to everything that we do. But there's a lot of upside. And when I think of the imaging piece, that you talked about for cancer identification or just some of the things where it assists and it actually enhances the human, right? It supports the human and the work that they're doing and improves that work. That's where I get really excited about it. And when I think about the application in pharma and how it can help me as a quality professional support me in making my job faster and some of the things that I do are more efficient or pull data for me and I can do data analysis now a lot faster. I can look for trends and things and not have to manually go through or drop everything into an Excel spreadsheet or something. I love that because now I can probably make better quality decisions from that. And
Huh,
that's what I'm hoping to
100%.
get from this. Yeah.
100%, right? So using the quality risk space and looking at your documentation and kind of going through this progression, there was probably a time, probably not, maybe not within our careers, but probably before, where you had binders and binders and binders, right? Of regulations and compliance documents that you had to go through and sift through to kind of say, okay, well, where is this component? And then I have this component and this section from this document needs to be brought into this area, and I need to cross-check it with that. And it would take you months, right?
Yes.
Well, and if you think about the amount of regulation that's increased over the years, imagine if you're still doing that by hand. So
Yeah.
wasn't it a great thing that computers were invented, and then you could put all of those documents electronically, and then you can carry them around with you instead of having to go to these gigantic libraries to go look for information?
Yes.
Okay, iteration one. Iteration two. What if we were able to take those documents electronically and be able to search through them to find information like a search engine? Okay,
Yeah.
well, that drastically speeds up the ability for me to have to go and find all of these pieces of information and gather all those pieces of information together. Okay, great. Iteration three. What if not, in addition to being able to grab those relevant pieces, we were able to get a summary of that information already tightly packaged, as opposed to having to say, I have to go read through these 15 other documents still, and then go compile that summary. That's where generative AI is right now. And that's where generative AI is starting to excel, is the ability to take all of that information, consolidate it down, right? As I tell people, when you look at Google and you look at search engines, right? Search engines were incredible when they first came out because you were able to take all this information that existed on the internet, and then you were able to collect it into a single area so that you could find relevant. Well, after that, what eventually happened is you started having ranking algorithms, right? PageRank algorithm came out. And then you were able to say, hey, based on the influence of this site, this is the site that you're probably most interested in getting to. Okay, great. So what happens over time? Well, what happens over time is you never leave the first page of Google. And oftentimes you don't leave the first or second recommended site.
Yep.
Okay, well, now let's say that you're at the first or second site and you're looking for a particular small piece of information within those two sites. If the machine is going to be able to summarize that information and put it together tightly and neatly for you, it just makes you do your job much more fast.
Yes.
Right? So the idea is, these are all things that are speeding up your workflow to get to the real problem. I think people tend to get stuck that whatever they're doing is the problem. The reality is whatever you're doing is on its way to solve a problem. So you're always chasing a bigger and bigger problem. And whenever you hit that milestone, there's a new problem to uncover or a new piece to perfect. So every time we hit one of these milestones, it's not a, oh my God, we're done. It's a, okay, we finished that. Now let's focus on something more.
Yeah. Yeah. And we oftentimes have to course correct when we get new technology too. Sometimes we swing, like, we'll do another segment sometime about my fears of TikTok. We swing sometimes too far. And then and then we course correct, right, too, a little bit because we're sort of awkward. We're kind of clunky when we first get into something. Maybe we go in full steam and we're like, it could do all of our things. And then we realize it can't because we make some mistakes. So, there's that learning too that happens. So, but this has been fabulous. Thank you for joining me. And I love being your friend too. So this is great. But we do need to wrap up and we can always do another one sometime. If our listeners walk away with one thing, just one thing about what we've talked about today, what might be that one takeaway that you'd want to leave them with for in terms of AI?
Yeah, I think the thing with AI is to be open-minded, right? To explore it. And there's a phrase I like that people fear things they don't understand.
Yeah.
And I think the reality is, I think we need to have some more education around what is AI, how AI works. And a lot of that comes down to math literacy, right? And computer literacy. So I think it's really important to just go and learn the basics, learn some of the basic understanding of what's going on. Watch YouTube videos from people who explain things in more layman terms. There's a bunch of great folks out there who do a wonderful job of breaking this down so that if you're not a PhD in applied mathematics or computer science, you can still understand this. Go pick up some of that information and start to familiarize yourself with that. Ask questions. Play with some of these technologies. Start to understand what it does well and what it doesn't do well for your use case. And I think over time, you'll get a better perspective as to where we're going with this, what it's going to be very successful at, and where it's going to still need a lot of work to be developed.
Yeah. I appreciate that. And I think that's just such a great practice to have with anything new is like I said before, yes, it seems scary sometimes. It's new, I don't understand it. There's a lot of big words. It seems like it's scary because some people make it scary. But just be open and ask the questions and seek to understand. I think curiosity is something that sometimes dies, and I wish it wouldn't, because I think if we were curious and we asked more questions, we might not shut down about some of these new things, and then maybe we'll be more open to using them in the right way too, and studying them instead of letting the technology run over us. Maybe we kind of become a part of it. And newsflash, it's everywhere already. So if you're still afraid of it right now, you probably should just start to embrace it in some way to understand, at least understand it. I went to a doctor's appointment just a couple weeks ago, and I was told up front that when you go into the exam room, the doctor is going to be recording this. AI is going to be taking notes on this session. We want you to know that. And I was okay with it. I get it. That actually helped the doctor, I think, be more focused on having a conversation with me because they weren't worried about having to take the notes, right? They were just listening and asking the questions. So I think that was just one example. I went to a drive-through the other day and it was an AI voice that was asking my meal. I don't go through drive-throughs very often. My kids were with me and I was like, "Oh my God, that's AI," because it was clickety clacking away on a keyboard in the background. And I'm pretty sure if you work in a drive-through and you're ordering a meal, it's a push of one button. So like I thought it was funny that they felt compelled to have to record all those extra noises with it to make it seem really real for the user, I guess.
Yeah, I think there is one danger with all of this AI that I do want to bring up that I think is really important is as we start to interface more and more with AI and become more reliant on it,
Yeah.
right? Because we're going to start to get a lot more assurance from it. It's going to start to give us the answers that we're looking for and that we're expecting. The one thing I am concerned with is we're going to lose the human connection that
Yes,
we need to have
I agree.
as a species because now we're starting to fall down these areas where things are starting to turn into echo chambers. Things are starting to turn very personalized to
Yeah.
whatever belief system I have, which just intensifies and magnifies what's going on. And I think we need to work on being exposed to new ideas, new concepts, and difference of opinion.
Yeah,
So that's the one area where I'm really kind of concerned that um, we're not going to get enough social interaction.
I agree.
So
And I
that,
love a good debate. Hence
yeah,
why you and I got along so well.
yes,
All right. Thank you so much, Mike. I appreciate everything you've shared today. I hope you had a good time. I think the listeners will very much enjoy all the knowledge that you shared today. Thank you.
Thanks again, Lori, for having me. This is fun. I'm happy to participate whenever you like. Right. This has been wonderful, and thanks again. And I hope you have a wonderful day.
What a great interview, Laurie. I love when someone takes complex ideas and makes them usable. And just my reactions, two words Mike used really stood out for me. The first word was deterministic, and the second was judgment. First, deterministic. Mike referenced finance teams, mining signals, using them to predict outcomes, good to bad. Pharma has been talking about this for years. As far back as 2008 in ICHQ10, it pointed to feed-forward controls. And now we actually have the power to model downstream processes based on current data and emerging signals. We should be doing much more of that, really. And even risk assessments. We can move beyond purely qualitative scores and grids, and our current frequentist approaches, which operate in a premise of saying, it never happened before, so it's unlikely to happen in the future. That assumption, it assumes a steady state, and in real operations, equipment wears, processes drift, context shift. So past frequency can be a very poor predictor of the future. So deterministic quantitative approaches like Bayesian updating lets us predict future likelihoods as conditions change. And we need to be doing more of that too. You know, ladies, when I was doing my PhD on QRM effectiveness, one conclusion I found, it was uncomfortable but true, we all need to be better at maths, you know. And I'm not naturally in love with math either, but I think in digitized operations, it's essential for robust control of digital systems and models. So hearing Mike say the same was music to my ears. But anyway, let me come to the second word, which was judgment, because I think decisions aren't just calculations. We layer them with values, and most companies publish, a value hierarchy. We usually find it in the mission statement, with a priority of principles and values that guide our decision making and our decision trade-offs. When we're looking at those trade-offs, production schedules versus quality, continuity of supply versus quality, when to extend an invitation or an investigation and learn more versus we need to close this deviation. That's judgment, aligning our choices with what the organization values. And AI isn't great at valuing yet. That's I think they refer to that as alignment, which is how we try to structure AIs with value systems. And I think that is still early days, early research, early work in that space. But, if you take a simple example of an AI decision support tool for investigations, we'll say the AI knows the target date is 30 days. A human on a day 29 might say we need more time to protect quality and look for an extension to be approved. But an AI, if it's misaligned or ignoring its specifications or priorities and value hierarchy, that could treat the 30 days as the most important value and prioritize that metric, making trade-offs to hit that deadline. And those trade-offs could be opaque to the human in the loop if we're not conscious of these challenges in AI design and training. And that's why the human in the loop matters so much. And I think before we plug AI into decisions, we need to understand how we make the decisions. As people, what risks matter most to us, what values dominate those decisions. We do it kind of unconsciously and intuitively. But if we're going to start looking at AI systems and computer systems to see what they're doing, we need to make sure that they're following those values that we have, and that the guardrails are in place so that when humans even override an AI decision or recommendation, we're confident that the AI doesn't learn the wrong lesson from us and drift out of alignment, because they're awful people pleasers, I understand.
Yeah.
ChatGPT tells me I'm wonderful all the time, So look, audit trails and explanations are good, they're essential, but AI governance, I think, will include monitoring the learning outcomes from the AI. It'll govern how models learn from the human overrides. It'll preserve alignment. These are critical considerations. Great care is needed there. And I think, we just had a sort of master class in clarifying all those basics so we can understand where it's all going. Yeah, what
Yeah.
did you think, Paula?
Yeah, absolutely, Val. I loved his interview, and again, just there's lots of folks. I mean, even though you can't literally open your computer, you can't open a newspaper, you can't read a media report without AI being there, and to some extent, we're being kind of overwhelmed. And many of our listeners will know that all three of us come from the PRST group in TU Dublin, the Pharmaceutical Regulatory Science team in Dublin, and I teach on the executive MBA for the life science team, and all of the executive MBAs have just come back from a week a furlough in San Francisco, and everything was AI. They said there was not one discussion that didn't have AI in it, and almost to this extent that yes, we get it, but we're a bit overwhelmed at the rate and the pace of change. And Mike referred to that, how tech folks are much more agile about adopting, oh, we're onto a new version of this, or, we've got a new tool and it's upgraded. And yet, traditionally our adoption of, new technologies and tools has been much more conservative in pharma. So we're a little bit on the back foot from that. And that's why I really liked the fact that his recommendation is to treat it like an 8-year-old, in terms of how many instructions you give it all at once. I totally get that. And more importantly, the fact, as you highlighted there, Val, the importance of keeping the human in the loop. Certainly for the moment, we're not in Star Trek territory yet. And it's critical when we come to these risk-based decisions that, obviously we can use all of the tools. It's great for speed and accuracy and efficiencies in doing that data analytic and even presenting those insights based on the available data. But you still need the humans to make sure that the right stakeholders are in the room to evaluate those outcomes, that your SMEs, your process scientists, and even your frontline personnel who may not have any handle on how data is analysed or how it's presented to them. But ultimately, they may have the key to unlock the problem that you have, irrespective of, how many events you've had in the past 5 years with this product. You were not capturing all of that tacit knowledge. The AI is not capturing the tacit knowledge when it's, doing the data analytics. It can only capture the explicit knowledge. And we know, from our experience with our other colleagues and from the knowledge management domain, only 20% or thereabouts of what we know in our organizational knowledge bases is explicit and therefore potentially accessible to the AI. 80% of what is known in our organizations is still in the heads of our personnel. And if we disconnect that 80% of expertise or experience or know-how, then how on earth can we expect to make sure that we're making those right decisions? Now, look, this is particularly important, and Mike emphasized this as well, where we don't have an accurate data set to generate the outcomes. In the case of a new product introduction, or certainly in the case of some of these advanced therapeutics, we don't have an available comparable data set that we can use that we might have in, biologics or in oral solid dosage, that we could say, oh, we have platform technology and we can base our information on prior knowledge. So it's, particularly important where our data is eliminated. So, don't get me wrong, I'm all in on using AI. I'm absolutely 100% sold on AI, anything that makes life easier. I've even gotten an air fryer recently, so there we go.
I'm still holding out, Nuala.
Yeah, I know. Yeah. Much easier. And I would see this using AI in a similar way. It's helping us with our data analytics. It's helping us with our scenario identification. It can even help us with our early first pass of our hazard identification, or even the quantitative analysis based on our criteria relevant to our risk question, which some of our, when we have a risk assessment team coming together, sometimes it can take them a long time to get to that, customizing their qualitative scales for likelihood of occurrence or something. I mean, obviously our severity is still coming from our, patient harms document and, our medical teams. But we're really relying on our risk assessment teams to come together and identify what is the likelihood of occurrence of this based on historical data. And so I love the fact that we might be using deterministic and predictive data to look forward rather than always looking back in our rearview mirror to determine whether a failure is likely or not. But the formal evaluation of the outcomes, and more importantly, the whole purpose, as ICHQ 9-1 tells us, the purpose of a risk management program is not to do your data analysis or even do your risk assessment. It is to implement actions arising from, your risk control decisions. And so the development of those appropriate risk controls will need the experience of the human experts from the frontline personnel who carry out those actions in order to ensure that our risk control strategy is robust and implementable in the given environment or within the given facility or on the current equipment constraints, or process constraints that we might have. And AI won't know that. It won't know that we have a constraint on a particular facility or equipment that may not be able to. It may come up with some great ideas on risk controls, but they may be entirely irrelevant in the context of our situation. So we still have to assess the accuracy of those risk assessments completed by AI, and it is just a tool, and it's going to make life much easier. It's going to make these risk assessments much faster, and it's certainly going to take a lot of the pain. Hopefully we're going to lose some of the bad name of, oh my God, I've been invited to a risk assessment. There's 2 days of my life I'm never getting back. Hopefully we'll be able to really use these tools to present the data in a way that therefore those humans in the loop can really help to make those decisions or clarify that the recommendations coming from the tool are good. So that's my feelings. That was a great interview, Laurie, and well done on capturing Mike and getting him to sit down for an interview.
Thank you. I guess I'll just close out too with a key takeaway. Thank you, Nuala and Val, and I hope that the listeners appreciated the talk. There is a lot to absorb, I think, from it. A lot of information is shared. There's a lot of terms I think we have to take in, but I'm just going to second, I think, what you already said to Nuala about the culture. Be prepared when you're bringing in an AI tool that you have the culture that's ready to absorb that and use that, and that it's targeted to bring those efficiencies. I think what we're hearing a lot is it's going to replace jobs, and in some cases it already has. I understand that. But in many cases, the intent is supposed to bring efficiencies, speed, remove some of those things that are maybe not value added that the humans having to do and the AI could do a little bit faster, or the analysis part of it. But at the end of the day, we as humans still have to review that work. We're still in the loop. And so you can't have a culture who's going, oh, it's going to do that thing. No, it's going to help me do my job better. And I have to be able to review that work and validate, or not, I won't use the word validate, sorry, verify the sources of where some of that is coming from. People who are using currently Chat GPT, and I have a lot of clients or interactions I've had where people have tried to have it write an SOP. It's quite limited in that capability. It will provide you a nice framework, but be aware that sometimes it's pulling information that's not actually there. You'll go to look for it, and that link doesn't exist, or that regulation's not exactly correct. So it's still not there, as we keep saying in this conversation. You still need to verify the sources of where things are coming from. But does it give you a great start sometimes and a framework and help you organize your thoughts? I think it does a really good job with that. And I think there's much more sophisticated tools that we could bring into pharma that help with deviation writing, risk management work. Just we need to prepare a culture that it's still the human is accountable for this work. So thank you.
And for me, Laurie, as well, that human in the loop is the key takeaway. And I loved what when Mike said about the highlights that the fact that humans, where there is an absence of data, in a new product introduction or something, humans are better, he said, of coming up with creative solutions for something we've never seen before. Those edge cases, as he described them. And I think we all have to consider those edge cases. And something just kind of pinged for me when I was listening to him, that ultimately the use of these AI tools does not eliminate the responsibility of the ICHQ9R1 decision makers.
Yes.
Much in the same way that outsourcing production to a CMO does not shift the responsibility for product quality and patient safety from the market authorization holder, and for those of us listening now that are new to the podcast, we had a superb episode previously on the podcast with our colleague Rosanna Buell on supply chain oversight. And it just resonated with me, that much of what she spoke about very practically could be considered here, in terms of outsourcing our data analytics to a suite of AI tools and hoping for the best in terms of the decision outcomes. Yeah. So there's still that level of oversight needed. And yes, absolutely embrace it, use it, test it, engage with it, teach people how to use it properly within the guide rails that we've talked about. But ultimately, the decision still lies with us, and the responsibility opportunity still lies with those folks who are releasing the product into the marketplace. And, again, as I always say, what's good for the patient is good for the business. So make sure you've still got that patient at the center of your decision making.
Yeah, that's a really good thought, Nuala, because there's a lot of people going to be involved in making sure that the AI is responsible in terms of what it's doing. But, at the end of the day, for most important decisions in a plant, there's one person accountable, whether it's the qualified person or the head of QA or whatever. So, that ensuring the best decision outcomes for that person is so critical. I've been doodling a formula here, folks, I think we need to understand the math. I think we need to make the values explicit. And I think we need to design human in the loop as a real capability, not a checkbox. Yeah, we've got an override system. So I think the map, the values, the guardrails, that they're clear, that the override rules are clear, that the rules for what the model learns from those overrides, I think that's important. And they're all so critical to turning AI into a trustworthy decision support. So there you go. Well done, Laurie.
Thank you.
Well done. But listen, before we sign off, Laurie, what goodies have you got for sharing for our listeners today in our links?
Yeah, so I got a lot. Actually, I had to control myself. I added 4 things, but the first 3 are really for our regulatory quality, for anyone for that matter, but those that are maybe really concerned about the regulations or how to decipher some of that. There's a reflection paper on the use of AI in the medicinal product life cycle. The second one is considerations for the use of AI to support regulatory decision making for drug and biological products. And then the third one is the EU AI Act. I highly recommend all 3 of these. Yes, I know that they're not going to be your fun historical fiction that you read before you go to bed, but I think there's great things in there to consider, especially the EU AI Act. I am not aware yet of a US act that is comparable in nature, and I think it's something that we're very concerned about in the United States as well. So take a look at some of those things. I think they're the guardrails that we need to consider when we're sort of unleashing this new technology that's going to have big implications out into the world. The last one's kind of fun for those that may be a little unsure about writing those prompts, how to kind of get the best use out of some of the OpenAI tools that are available. There's actually something called OpenAI Academy that you can use for free. There's learning how to write prompts. There's a 3-part video series that kind of helps guide you through how to get the best out of maybe ChatGPT or some of those open AI tools that you're using and helping you to get the best output from it. So I thought that would be kind of a fun interactive exercise, especially for folks that may be newer. I have some friends that I've been talking with that are like, I'm sort of scared. I haven't gotten in there yet. Maybe if you do something like this and just take a few minutes to watch a video and play around with it, that might be fun too.
Excellent. Brilliant, Laurie. My 9-year-old is able to talk to Siri and Spotify to get exactly what he wants. So yeah, this learning, the next generation are going to be very good at prompt engineering, but those of us who speak in full sentences and not in text speak could probably do with that little video. So we look forward to that. So thank you everybody for listening in today. For those of you who haven't subscribed yet or maybe new to us, please do hit that subscribe button and we will magically appear in your podcast feed every month. We're back here every month discussing something to revolutionize how we do risk. So it's a goodbye from Nuala.
Goodbye from Laurie.
And goodbye from Val.